This is our discussion on experimental design, specifically using the scientific method to conduct experiments. It's important that we use good experimental design so we can establish a cause and effect relationship with the variables that are being studied. A good cause-effect relationship means that you have a controlled experiment, which means only one variable is being adjusted or changed at a time. Specifically, we have three different types of variables that we can talk about, three different vocab words, if you will. We have controlled variables. Those are items of the experiment that are being maintained the exact same throughout the entire experiment. We have the independent variable, which is the variable that the scientist or the researcher is specifically trying to manipulate. And then finally, we have the dependent variable. It depends on the independent variable to change. It's going to change as a result of the independent variable. Typically, the dependent variable is what's being measured because it's being measured as a result or being observed as a result of changing the independent. So the dependent is going to rely on the independent. It depends on the independent. So here's an example. On the left-hand side of the screen, we have a test tube. Inside that test tube, we have a specific quantity of magnesium powder, and we have a specific volume of hydrochloric acid, and then that acid has a specific strength. So these three things, the volume, concentration, and mass of the powder, are controlled variables because they're all going to be the same for each of these three test tubes. Then the water bath is also going to be controlled. It's going to have controlled variables. There's going to be 400 milliliters of water in a 600 milliliter water bath. And we're going to do that 3 times, so 3 different water baths, each with 400 milliliters. Again, these variables that are being held constant are called the controlled variables. Then the independent variable, the one that the researcher is specifically changing, is the temperature of the water inside the water bath. We have a 1 degree, a 22 degree, and an 80 degree water bath. That's what the researcher is specifically manipulating. Now, what the researcher is going to measure is how long does it take this balloon to inflate, to go from being laying over to standing upright because it's filled with a gas, which is what happens when magnesium reacts with the acid. That time is the dependent variable because the time difference, the cause and effect, the time, should be related to the temperature of water. Now, we can talk about the actual process of the scientific method. We like to talk about it in terms of FIAC, which is a teaching tool to learn about the scientific method. Scientific method is really just a way of thinking that establishes cause and effect using those controlled experiments, but the acronym FIAC, problem, hypothesis, experiment, observations, conclusion, is a really useful tool for trying to explain the general parts that go into the scientific method. So you can see what those different parts are right here. But what I'd like to specifically spend time on is the hypothesis and how to write a good hypothesis. So the hypothesis is difficult to write because it's needing to be very specific to be a solid hypothesis. A lot of times students just say, oh, it's an educated guess, which I understand why it's taught that way because you're taking past experiences to write a hypothesis. However, I don't like the word guess because it should be stronger than that. It should be a plausible answer, a good likely answer to your question. Guess doesn't seem to convey that same meaning. So the hypothesis, we often try to teach it in an if-then format where the words that come after if would be the hypothesis, and then the words that come after then would be your prediction. So if, your hypothesis, then the prediction into an entire statement. The general format for the hypothesis would be the independent variable, in this case, water bath temperature, how that affects the dependent variable, what we're measuring. That would be the time for the balloon to inflate or the reaction rate. So water bath temperature in terms of the reaction rate. So for, as I was just saying, increasing reaction temperature increases reaction rate. That's a hypothesis. That's a possible answer to the question, how does temperature affect reaction rate? Again, going with the same pattern, the prediction would be the independent variable, so that's water bath temperature, a specific one and what that will do to the dependent variable specifically. So specific kind of water bath temperature, cold, medium, hot, and what that should do, how that should change the dependent variable, the time it takes to inflate the balloon or the reaction rate. Specifically, higher temperatures will cause the balloon to inflate more quickly. Higher temperatures will cause the balloon to inflate more quickly. If done correctly, the hypothesis should state how that condition will specifically, I want to emphasize the word specifically, affects the science phenomena, in this case reaction rate. How does the specific condition specifically affect the reaction rate? Increase, decrease. Not just affects reaction rate, but increases the reaction rate. So we know that there should be an effect. We know it should be a cause-effect relationship, but we want to know specifically what that effect will be. And then to put that into the terms of independent and dependent variables, we would say how changing the independent variable specifically affects the dependent variable. And then finally, if we do a prediction correctly, that should describe what we will see if that hypothesis is true. So if warm water bath increases reaction rate, that's my hypothesis, then the 80-degree water bath, so I'm being specific, will react in a shorter amount of time than the 1 degree or the 22-degree water bath. Want to restate changing the condition, and then again, it's in terms of independent versus the dependent. So that's how we can use good experimental design to have a controlled experiment, only changing one variable at a time, and that variable would be the independent variable. You have controlled variables, those that stay the same, and then the dependent variable is what's responding or what's dependent variable depending on the independent variable.